Picture a phone that has 40 apps installed, 12 accounts logged in across 4 of them, and a media feed that never stops loading thumbnails in the background. Now imagine that phone doesn't sit in your pocket, it sits on a rack, running around the clock, and you are never going to physically pick it up to see how full it is. That is the actual problem behind Android device storage management on a rented fleet, and it looks nothing like managing storage on your own personal phone. I run a real cloud Android phone farm out of Singapore on dedicated hardware, and every device we touch has a fixed amount of onboard storage soldered into the board. Nobody hands us a virtual disk we can resize with a slider when things get tight. When a device fills up, it fills up, and the apps on it start misbehaving long before Android itself actually refuses to write another file. Everything I'm about to walk through is stuff we learned by watching real devices choke, not by reading a spec sheet. Here's the thing nobody tells you until you're running more than a couple of devices. A phone sitting in someone's pocket gets used in bursts, then it gets put down. It idles for hours at a time, and during that idle window, Android's own storage manager gets a chance to quietly trim caches in the background. The person holding it also occasionally opens settings when things feel slow and clears something out of frustration, even if they don't know exactly what they're clearing. A rented device running multi-accounting operations never gets that idle window. Apps stay logged in across sessions around the clock. Media loads continuously because that's what the automation is there to do. Scripts often keep an app in the foreground or wake it up on a schedule, specifically so the operating system doesn't suspend it and lose the session state. Android's background cache eviction depends heavily on memory pressure and foreground activity, and a device that's constantly busy simply gives the system fewer natural windows to clean up after itself. The result is that storage on an actively used cloud device fills up noticeably faster than storage on a phone sitting quietly on someone's desk, even when the raw amount of app usage looks similar on paper. We've watched 2 devices provisioned identically on the same day end up with wildly different free space 3 weeks later, purely because one of them was running a media-heavy account and the other was running lighter, mostly text-based automation. Let me give you an actual number instead of just talking in the abstract. We had one device that started a week with about 9 gigabytes of free space on a 64 gigabyte drive. By the end of that week, it was down under 1 gigabyte, and it wasn't running anything unusual, just 4 accounts on one messaging app and one social app, both scrolling media on a normal schedule. Nobody touched that device by hand the entire week. That drop happened purely from cache and normal app growth, and if we hadn't been watching the number daily, we would have found out about it from a write failure instead of a dashboard. Every installed app on Android gets its own directory, split roughly into 2 parts, a data folder and a cache folder. The data folder holds things the app considers permanent. Things like SQLite databases, downloaded files, login tokens, saved drafts. The cache folder holds things the app considers disposable, thumbnails, temp downloads, prefetched media, log files it doesn't really need once it's been written. In theory, that cache folder is the app's own problem to manage, and Android is supposed to be able to reclaim it whenever the device comes under storage pressure. In practice, a lot of apps are surprisingly conservative about trimming their own cache. Some of them only actually prune it when a human opens the app's own storage settings screen and taps clear on a device you are not physically holding. That tap simply never happens unless you have built a process that does it for you on a schedule. The other quiet consumer is the apps themselves getting bigger over time. APK sizes trend upward release after release because apps keep adding features, bundling more native libraries, and shipping larger resource sets with every update. A device holding a dozen apps that each update every few weeks accumulates that growth steadily in the background, and it's easy to miss entirely because no single update looks alarming when you check it on its own. This is where the distinction between clearing cache and clearing data actually matters, and is the single most important thing to get right on an account-heavy fleet. Clear cache removes only that disposable folder. The app just rebuilds whatever it needs the next time it runs. It is safe to do routinely, and it should not log anyone out or lose any state, because the app was never supposed to treat that data as something it couldn't afford to lose in the first place. Clear storage, sometimes labeled clear data, is a completely different action. It wipes both the data folder and the cache folder together, which means login sessions, saved preferences, and local databases all go with it. On an account-heavy device, that's the difference between freeing up a gigabyte of space and having to manually log back into every single app on that device by hand. We treat clear storage as a last resort, never a routine maintenance step, and we never run it against an app holding an active session unless we've already planned for the re-authentication that follows. Picture what that actually looks like on a device holding 6 separate accounts across 3 apps. That's not one login screen you deal with, that's 6. 6 passwords to type back in, 6 two-factor codes to wait on, 6 verification texts that might land in a queue behind each other. If any of those accounts also flag the login as suspicious because it came from a fresh session with no cookies and no history, you're not just retyping a password, you're dealing with an account review that can take hours. That's the actual cost of running clear storage carelessly, and it's why we never treat it as a quick fix. If you're scripting this across a fleet, rather than tapping through settings screen by screen, there's a command called pm clear that does exactly the same thing as clear storage, just from the command line, and it is just as destructive to session state. There's a gentler command too, called pm trim caches, that asks the system to free up cache space across apps without touching any app's actual data. We lean on that second one heavily, and we treat the first one the way you treat a command that logs somebody out, because that's exactly what it does. The most useful habit we've built into our routine is checking storage before an app starts failing, not after. A quick command against the data partition tells you how full a given device actually is right now. Another command, along with checking the size of specific app folders directly, tells you which package is actually responsible when a device is running tight on space, instead of you guessing based on which apps feel like they'd be the culprit. We check this per device rather than trusting some average across the whole fleet, because storage consumption tracks what that specific device has actually been doing, not some fleet-wide baseline number. A device running one media-heavy account behaves completely differently from a device running lighter, mostly text-based automation, even if both of them were provisioned identically, on the same image, on the same day. Android does have its own low storage warnings built in, but by the time those fire on a device you're managing remotely, the apps on that device have usually already started throwing write errors or silently failing to save something without telling anyone. Catching that trend a few gigabytes earlier, while there's still headroom, avoids that failure mode entirely, and it's a lot cheaper than debugging a mystery failure after the fact. App updates are one of the few storage costs you genuinely can't clear away, since the new APK version replaces the old one on disk rather than sitting alongside it. What you can actually control is when those updates happen, and whether they happen in a coordinated way across the fleet, rather than whenever each individual device feels like pulling one down. Letting every device auto-update on its own separate schedule means storage and behavior changes land unpredictably, all at different times, which makes it genuinely hard to tell whether a storage spike came from ordinary cache growth or from 12 devices happening to pull the same large update overnight. Staging updates, or at minimum tracking which devices updated and exactly when, turns what would otherwise be a mystery storage jump into an expected line item you already accounted for ahead of time. Messaging and social apps that handle photos and video are consistently the biggest cache consumers on any device we run, because their whole design is built around loading media fast, which means caching it aggressively by default. An app showing an image-heavy feed is, by design, downloading and locally storing a lot of thumbnails and full-resolution assets as a session scrolls through content, whether that scrolling is done by a human or by automation behaving like one. Now multiply that by several logged-in accounts sitting on the same device, each one with its own session and its own cache directory tucked under the same app's folder structure. It becomes easy to see why a single app can end up responsible for the majority of a device's used storage all on its own. Checking per app storage, or running a quick size check on each package's folder, usually points straight at one or two apps rather than showing an even spread across everything installed on the device. Sometimes the right move isn't clearing individual app caches at all, it's resetting the device entirely and reprovisioning it from scratch. If storage is consistently tight across most apps, rather than concentrated in one or two, if performance has degraded in ways that clearing cache just doesn't fix, or if a device has accumulated enough account history that untangling what's actually safe to clear becomes more work than starting fresh, a full reset is faster and more reliable than surgical cleanup. We treat that reset decision as scheduled maintenance, not as an emergency response we're scrambling to handle. A device that runs out of space in the middle of an active session is a genuinely worse outcome than a device that gets reset during a planned window, well before it ever gets close to that edge. Planning the reset in advance beats reacting to a failure every single time. None of this requires anything exotic or clever. It requires checking storage on a schedule instead of waiting for an app to fail on you. It requires actually distinguishing cache clears from data clears, so you're not accidentally logging accounts out by accident. It requires watching which apps are actually responsible for growth on a given device instead of guessing, and it requires treating app updates and device resets as planned events you scheduled, rather than surprises that show up on their own timeline. On real hardware with fixed storage, there is no shortcut around any of this. The device only has what it has, and the apps running on it will happily use every last bit of it if you let them. That's the whole job really, watching the fleet closely enough that storage never gets to decide what happens next on its own. If you want to see this handled properly instead of guessed at, we run real cloud Android phones in Singapore on dedicated hardware, and every single one comes with its own persistent SG mobile IP. You can find us at cloud.one if you want to see how we actually provision and maintain a fleet like this in practice. If this was useful, go ahead and subscribe. There's more of this operational stuff coming.